Now that we've talked about matrix operations, we're going to use those operations to solve matrix equations. Here I have two different versions of matrix equations, and in the next slide we'll go over the last one and how to do it with a calculator. First we have addition on the left-hand side, and you're going to treat these matrices just like you would with numbers. Whenever I have an equation like 2 plus x equals 5, the method I would use to get x by itself is to subtract away the constants, and that leaves me with 3. We're going to do the same thing here, except you're subtracting away the matrix in front of x. So I'm going to subtract 1, 2, 3, -1 from both sides. And from here, you're going to use matrix subtraction, which we covered in the last video. 4, 5, -3, -2. And a way I can check my work is actually to plug that back in and just make sure that adding these two matrices together is actually going to give me that result. Over here on the right, we have multiplication with a scalar. Again, the x represents an unknown matrix that got multiplied with 2 and resulted in 0, 1, half. Now this one's pretty simple, so you could probably logic your way through it, but let's see how you would do it algebraically in case you see one that's more complicated. What I would do algebraically to get rid of the 2 on the left-hand side is to divide everything by 2. But I want to kind of change up that language a little bit. Division is actually multiplication by something called the multiplicative inverse. Multiplicative inverse is probably a word you haven't heard before, but what it means is the number, the inverse, that when you multiply to the original, you get something called the identity. For different number systems, you have different multiplicative inverses and different identities. But when it comes to real numbers, like you've worked with in all of algebra, the inverse of a number, like 2, is 1 over 2. Because when you multiply those two together, you get the real number identity 1. With matrices, the identity is a little different than just 1, and therefore the inverse is going to be a little bit different than just 1 over the original matrix. And this is kind of the explanation for why we don't have something that is strictly considered matrix division, because truly division is just multiplication times the inverse of the number. So that's a long-winded way of saying I'm just going to multiply by 1/2, but that's a hint that in the next video, multiplicative inverse is going to be a very important vocabulary word. Okay, in this case, now that we've gone through all of that, the 1/2 times the 2 becomes a 1. And it is true, this is just another property. I thought I was done with these properties, but here's another property. The identity is something such that when you multiply it times a number in your number system, it should result in that number again. So in the real numbers, the identity is 1 because 1 times anything is itself. So that tells us that this left-hand side is just going to be x because 1 times x is just x. And on the right-hand side, we can use our scalar multiplication that you practiced in the last video, and we'll get a result of 0, 1/4.